So this exercise is related to the projectile motion. The last session we discussed like the projectile motion, the horizontal and the vertical components are there. A two-dimension motion is called a projectile motion. The horizontal velocity does not change as there is no air resistance to oppose, and the vertical component, the acceleration is due to gravity, and when it is going up, it decelerate. When it is coming down, it will accelerate. And the range depends on the horizontal component and the height depends on the vertical component. So we'll do the questions from the projectile. It's having questions from different boards like Cambridge, EdXL, AQA. The main purpose of having the variety of the question, like you get a better understanding of the topic. Question 33. A rugby player kicks a ball off the ground at an angle of 35.0 to the horizontal as shown. The ball reaches a maximum height of a 5 meter before returning to the ground. Show that the initial speed of the ball is about 17 meters per second. How we can work out the initial speed? We know the maximum height is there. We know the launching angle is also given to us. We need the speed at which it was launched. Basically, the total speed which it is launched, that is what we want. So if the vertical component, look, if the vertical is given, if the vertical is given, like height is given, so we'll take a vertical component, and whenever we take a vertical component, we use the equations of the motion. So the vertical height, the height is 5 meter. What about the initial velocity? Initial velocity will have the two component, like this velocity is u. Example we called u. Then this u will have the two component. One of the component is with an angle. So the component which is with an angle, that is u cosine 35. And the component which is opposite to the angle, that's equals to u sine 35. So u sine 35 is responsible for the vertical motion. So we use, and what about the acceleration? It will have a deceleration, which is again the gravity. So A is equals to minus 9.8 meters per second square. So you have the initial velocity, which is u sine 35. You know the maximum height or the distance, which is we can say s or you can also say h. What about the velocity, the vertical velocity at the maximum height? So vertical velocity at the maximum height is 0. And whenever we are using the vertical component of the motion, it means we will always use the equation of the motion. So if I have the initial velocity, I have the final velocity and height. So which equation of motion we can use? We can use a equation of the motion in which 2as is equals to v square minus u square. So 2as is equals to v square minus u square. So it will be 2. The gravity is what? Minus 9.8. What about the vertical displacement? The vertical displacement is 5. The final velocity is 0 minus. What about initial velocity? So initial velocity is u sine 35 and whole square. We need only u. Now we simplify this. 9.8 times 2 times 5. What's the answer?
Minus 9.8.
Yeah, negative 9.8.
It's minus 98.
Yeah, because it will be 2 multiplied by 5, 10, right? Minus 98 will be there. So this is negative 98. This will be negative u square and sine 35. What is the sine 35 square? First take sine 35 and then square that.
0.33.
0.33. So this will become 0.33. So 0.33 is multiplied other side. This negative will cancel with negative. 0.33 is multiplied other side divided. So 98 divided by 0.33, that is u square. But you need u, so we'll take a root. What's the answer? 0.9.8 divided by
17.23.
17.33. So that is what we have to show. So the initial velocity or the launching velocity is how much? That is 17.23, which is approximately about 17. Is it clear?
Yes.
So acceleration is 9.8, negative 9.8 times 2 times 5. So we got negative 98. And then we just simplify to get the value for u. The next part, after traveling a horizontal distance of 22 meters, the ball reaches the goal, which is 3 meters above the ground. To score, the ball must be more than 3 meters above the ground. Like if you have seen a rugby, when a player kicks the ball, it should cross the bar, like above the bar, not below. And the bar is 3 meter between the two parallel poles. So deduce whether the initial velocity of 17 meter per second is sufficient to score. And this is 22 meter. So means when he kicked, the place where he kicked, that is 22 meter from the goal. And he launched with a velocity of 17 meter per second at an angle of 35 meters per 35 degrees. So maybe what might be the trajectory? Its trajectory might be like this. So it means that means there's no goal, and its trajectory might be like this. So means there will be a goal. We want to find the height. Like we want to find what is the height when it traveled
Height
22
after
meters.
22 meter.
Yeah, what will, like what is the position or what is the height when it is at 22 meter from the point where we kick the ball? That is the main question, because if our answer the height is above 3, it means yes, definitely it will score. And if the height is below 3, then it means it will not, or the player will not score. So first we will find how much time it will take to travel 22 meters. So horizontal, whenever you're taking a horizontal component, there's no acceleration. So we use the formula speed is distance divided by time. So time, we can relate the two by time. So we have the formula that speed is equals to distance over time. So if I need the time, it will be distance divided by speed. So distance is 22. And what speed? We need a horizontal, like we take a horizontal speed. So it will be 17 cosine 35. So this will be 17 cosine 35. How much time it will take to reach 22 meters? What's the answer?
1.58 seconds.
So 1.58 seconds it will take. Now, using this 1.58, we'll find what will be the position of the ball above the ground, the displacement. So how to know this? So we'll use again equation of the motion. Like if I need the height, we don't know what height is there. So we are finding that height after 22 meters using a formula S is equals to ut plus half at square. But what equation of the motion, we always substitute the vertical component. We never substitute the horizontal component, because vertical component, the object is acceleration, accelerating. The horizontal component, it does not accelerate. So S is equals to ut. U is the initial velocity. What initial velocity? So we take a vertical velocity. What is the vertical? So 17 sine 35. So 17 sine 35, that is a vertical velocity. Multiply by time 1.58 plus 1 by 2. And what acceleration I will take? Minus 9.8. Look, when you consider a motion, remember one thing. When you are in a projectile, when you take a full projectile motion, you'll consider as minus 9.8. Or when you're considering a half motion, when it is going up, you will also consider negative 9.8. So both cases you consider as negative 9.8. If it is you're taking a full motion, negative 9.8, or you're taking a half motion when it is going up, also negative 9.8. But when it is launched from a certain height, then you will take as positive 9.8. And what about ut plus half et square? So it will be 1.58 square. So what's the answer? 17 sine 35 times 1.8. Then it will be plus minus is minus 9.8 divided by 2 into 1.58 square.
3.17.
3.17 meter. So it means if we compare,
It will goal.
yeah, so it means the player will score a goal because it is above 3 meters. Is it clear this one? Anyone having a doubt or a question about this?
No.
You will take the acceleration only positive when a projectile is launched from certain height and it is coming down. That is the only case when you take acceleration as positive. Otherwise, when even you're talking about half motion, you'll take as 9.8 meter. Even you're talking about full motion in which the projectile goes up and coming down, you will always take as 9.8. So either upward motion or a full motion, it's negative, but only a downward motion, it is positive. So whenever there's an upward motion, it's always negative. When it's a full motion, we consider acceleration as negative. When it is like in this case, when I will solve a question, a skier is moving and he's coming down. So what I will take acceleration, I'll take as positive 9.8. But if it was, but in this case, like if he was coming down like this, horizontally, like, and he's coming down in this manner, then what I will take, I'll take as positive 9.8. But when if he's going up and then coming down, what I will take, I'll take as negative 9.8. And that is what the case here, that it is, he's going first up because that is the trajectory he will follow, the path he will follow. So question 34, a skier moving at 25 meter per second skis off a ramp. A ramp is angle upward at an angle of, the ramp is angled upwards at 10 degrees to the horizontal as shown. There's a flat surface that starts 30 meter from the ramp. The flat surface is 2.9 meter below the ramp. Deduce whether the skier reached the flat surface before landing. You may ignore any effect of air resistance because whenever we solve a projectile question, we always ignore the air resistance. Like we ignore there is no air resistance opposing the motion. So first, how it can be done? We can work out. We have the velocity. We have velocity is there 25. So this first velocity will have the two component. One of the component is with an angle. Another one is opposite to the angle. And this time when for a skier, he will have the both component because why he will have both component as initially he's having an angle. If it was initially horizontal, then it won't have a vertical. It will have only horizontal. So what will be this component? So this is equals to with an angle. So 25 cosine 10. This is opposite to the angle. So that is equals to 25 sine 10 degrees. So we have the horizontal and the vertical component. Now, what we do, Using the horizontal component and the distance, we'll find how much time it will take for him to reach 30 meters. And using that 30 meters, we'll find using that time to reach a 30 meter, then we'll find his displacement. So maybe he, after reaching 30 meters, horizontal covering 30 meter, maybe he's here, or maybe he's at this position. So we don't know. So this is our origin. The first thing what we do, using the horizontal component and using a distance, we'll find how much time he will take. So the same formula, that speed is distance over time. This is only valid for the horizontal component. The vertical components, we cannot use this formula because the vertical there's acceleration. So if I need the time, time will be distance divided by speed. So what is the distance? 30 meter. And what is the speed? 25 cosine 10. How much time he will take to cover 30 meter?
1.2.
1.2.
1.22.
1.22. Okay. 1.22 seconds he will take. Now using this 1.22 second, we'll find what is his displacement. So again, we'll use this formula. S is equals to ut plus half at square. And because I'm taking a full motion, so what I will take acceleration, positive or negative?
Negative.
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 So we just substitute the values. So initial vertical will be there, 25 sine 10. No, vertical velocity will not take as negative. We'll only take the acceleration as negative. Initial vertical is there. So this will be initial vertical velocity, which is 25 sine 10 degree. Multiply by time, he's taking 1.22 seconds minus 1 by 2. Acceleration is 9.8 because we ignored the effect of air resistance. Ut plus half at square is there. So 1.22 square. What is the final answer for the displacement?
I'm getting -2.
If you're, yes, fine. You're getting a -2. What does it mean? It means that for this skier, he will, after 30 meters, he will be below the point where he jumped, or he will be below the point where he started.
2
So
meters
means
below.
he will be 2 meters below. So means, like example, he will be, as we are getting a -2, so means this is a displacement -2. So what will the height above the level? So means he will be 0.9 meter above the flat surface. If you were getting a positive answer after solving this, and we got a positive answer, let's say our answer was 1 meter. So then what does it mean? It means from a point where it is launched, he's 1 meter above the point where he started. So if this is 1 meter, so what is the total height above the ground? So total height above the ground will be 3.9 meters. So it will have the vertical velocity and the horizontal velocity. The vertical velocity will change. The horizontal velocity won't change. Vertical velocity will, first he will decelerate and then he will accelerate. But because we are taking a full motion, whenever you take a full motion, you will always take as acceleration as -9.8, irrespective whether he's at the start of his journey, like maybe he's going up or maybe he's coming down. But you will take, when you're talking about the full motion, you will always take acceleration as -9.8. So when we solve that, we got that it's 2 meter. We got that he will be 2 meter below the point where he started. So means how much, what will the height above the ground? Means he will be 0.9 meter above the flat surface. So the question was,
It
deduce the
means he will be on the curved surface.
no, in after 30 meters, after covering a 30 meters, means he will be 2 meter below the point where he started. So this is a 30 meter. Where is 2 meter? 2 meter will be somewhat here.
Yeah.
So means he's 0.9 meter above the flat surface. So means he will not hit the curved surface. He will. So the question is, deduce whether the skier reaches the flat surface before landing. So he reaches a flat surface before landing.
He reaches it.
No, he's deduce whether the skier reaches a flat surface before he land. Like this is a flat
He will
surface.
land at 2.
He will not land at 2. What is the trajectory he is following?
At 30 meter, he will be 0.9 above.
At 30 meter, he will be 0.9 meter above the surface, the flat surface. So means
Okay, I got it.
like this is the trajectory he's following. And this is a curved surface, which becomes flat here. So he is from the point where we launched, like example, if we consider this as a horizontal. So what is his position? He's 2 meter below the point where he started. And this total was 2.9 meter. So means he's 0.9 meter above the flat surface after covering 22 meters. The after covering 30 meters, I mean. Is it clear?
Yeah.
Yes, sir.
The next is another skier travel along the horizontal surface with the initial speed of 23 meters per second.
I have
She she comes to rest after traveling a distance of 43 meters. Calculate the average force required to bring her to rest. The mass is given. So actually, we'll use a Newton's second law, which is F is equals to ma. We have the mass, we will find an acceleration and multiply to get the force. But how to get an acceleration for a, because the F is, you can use different F is equals to ma can be used, or you can also use the concept of the, because he, in the question, he traveled horizontal surface, initial speed was 23, and she comes to rest. Whenever, like if I say an object is moving at a speed of 2 meter per second, or having a mass of 5 kilogram. So what is the kinetic energy? It will be half mv square. So it will be half. The mass is 5 and the velocity is 2 square. So 4 into 5 makes 20 divided by 2. So we'll get 10 joules. So means if an object is having 10 joules of kinetic energy, how much energy do I need to stop this object? So I need the same amount of energy to stop an
10.
object, 10 joule. So same, we can also use the concept that if I know the speed and I know the mass, so I can find how much kinetic energy this object possesses. And to stop an object, my kinetic energy will be equals to work done. Because I want to stop an object, so all of the energy I have to use is should be equivalent to the kinetic energy of an object. Because if my energy is less than the kinetic energy, the object will not stop. So simply what we can do, we can use a formula, kinetic energy will be equals to work done to stop, and half mv square is equals to force into distance. So we'll have four mass, we have velocity, we have distance, so we can work out the force as well. This is one way of doing a question. Another way is working out the acceleration of the object. Like as you have the values, you will work out the acceleration first, and from acceleration using a formula F is equals to ma. Both will work, both will give the same result, same answer, but approach is different depending on how you attempt the question. Is it clear, this one?
So if we use the
The D
equation
will be 43 meters.
D will be 43 meters. Yes, Mohammed
sir, if
Abdul
we
Rahman.
use the equation 2AF is equal to v square minus u square, then after finding acceleration, we use F is equal to ma. Then that
Yes.
would work.
Yeah, that will work. That's what I'm saying. Both will work, but depending on like both will work, but first finding an acceleration, first find that you have to find a time, then acceleration. So it will be a long method. That's why the second method is preferable. So simply remember, whenever we use energy to stop the objects or moving objects, it's always the work done equals to kinetic energy. The next is an explosion projects a rock into explosion projects a rock into the air with a velocity of 50 meters per second at an angle of 40. Show that the rock would reach the maximum height of about 3 seconds after the explosion. So when it reaches the maximum height, what is the final velocity? Final vertical velocity. So it will have the two velocities. One is the horizontal
0.
and then the final will be 0. So the horizontal velocity will be equals to 50 cosine 40 and the vertical velocity will be equals to 50 sine 40. It reaches the maximum height h. At the maximum height, vertical is 0. Horizontal will be same because we assume that there is no air resistance to oppose the motion. So we need just a time we can use. And what about the acceleration or deceleration? So it will be minus 9.8 meters per second square. So we can use a formula V is equals to U plus AT. V is the final vertical, that is 0. U is the starting velocity, so vertical component, it will be 50 sine 40 minus 9.8 into T. When we simplify, it will be 9.8 T is equals to 50 sine 40. So T will be equals to 50 sine 40 divided by 9.8. What's the answer? How much time it will take to reach the maximum height?
3.28.
3.28, which is about, because the question is about, so 3.28 seconds. The rock moves in the direction of a hill. The side of a hill is at a 20 degree to the horizontal, as you can see here. After a certain distance, the rock land on the side of the hill. Deduce whether the rock hit the ground before it reaches the maximum possible height. Because what are the possibility during an explosion? Maybe as it is reaching it does not reach the maximum height, but it hits again. The trajectory might be like this, or trajectory might be like it's going up and then it hits the hillside when it is going up. So we have to deduce whether the rock hits the ground before it reaches the maximum possible height. What was the maximum possible height? The maximum maximum possible height is not given, but we know the angle is there, which is
After 3
40.
seconds.
Yeah, after 3 seconds, after 3 seconds it will reach the maximum, or 3.28 second it will reach the maximum possible height. So what we can do, first we can find the maximum possible height. What will the maximum possible height? And we will compare this with a hillside. Like what is the height of the hill? How we'll get the height of the hill? Look, if I
Height of the
know,
hill after 3 seconds.
no, not height of the hill after 3 seconds. We will compare the two positions. What we are doing, first we'll find the height of the rock, the maximum height the rock can have. What is the maximum height the rock can have? So we will use a formula that 2as is equals to v square minus u square. We will find the maximum height. What is the maximum height? So it will be s is equals to v square minus u square divided by 2a. So final velocity is 0 square. Initial velocity was 50 50 sine 40 whole square divided by 2 into negative 9.8. So it will be negative 50 sine 40 square divided by minus 19.6. What's the answer? Negative cancel with negative. So 50 sine 40 divided by 19.6. What is the height? What is the maximum possible height for the rock?
52.7.
52.7 meter. Means the rock will be at a height of 52.7. That is first thing. Then how much horizontal distance the rock has covered after 3 seconds? This distance, how much? So how we can work out if you know the horizontal component? So distance is speed multiplied by time. The horizontal component is what? It will be equals to 50 cosine 40 multiplied by time. It was 3.28, or let's say we are taking 3. What is the distance?
Total will be 114.9.
114.9 or 115 I can take. So 115 meter means this is when the rock is at the maximum height, it will cover 115 meters. Okay. Now what we'll do, we'll find the height of the hill. If the length is 115 meter, what will be the height of the hill? If the height of the hill is more than 52.7, it means the rock will definitely hit the hill. If the height of the hill is less than the maximum height of the rock at this position, then we can identify that it won't hit. So what about the height of the hill? You will use a triangle.
10, 20 multiply 115.
So the angle is 20 degrees and this is 115. So a right angle triangle is there. So this is a base for you. This one is a hypotenuse and this is a perpendicular. You need a perpendicular. So you have a tangent theta is equals to perpendicular divided by base. So tangent to 20, the perpendicular is unknown and the base is there 115. So 10, 20 multiplied by 115. What is the height of the hill?
41.9.
So hill is 41.9 meter. So means the rock, the question was deduced whether the rock hits the ground before reaching a maximum height. So when the rock reaches a maximum height, the rock will be at a height of about 53 meter and the hill is only about 42 meters at that same horizontal distance. So it means the rock will not hit the hill when it is before reaching the maximum height. Like if I draw this, the figure, say this is 115 meters and this is a hill which is 41.9 or let's say 42 meter and it was making 20 degrees. The rock was projected at an angle of 40 degrees and the initial speed was 50 meter per second. The rock will be at this when it is will cover 115 meters. The rock is still like it is at its maximum height. And that height is about 51 meter or 52 meter, I guess. 51, what was the answer for the height? The maximum height?
51.7, I think.
51.7 meters. So means the rock is 51.7 meter and the hill is only 42 meters. So it means the rock will not hit the hill when it is going up. It will hit the hill when it is coming down because the hill is, the inclination of the hill continues. So hill is like this. So when the rock is coming down from its maximum height, then it will hit the hill. Is it
We have to
clear?
assume that the hill never stops going up.
Yeah, because the continuation is there. If you see this part, they just say hillside. So it's just going. Is it clear, this one, the question related to projectile?
Yeah.
So I'll share this exercise as well as a weekly homework. Any question or doubt related to the class?